Welcome to qnawire.
Hi, so for this question, we're directly given the amount of mole that we added of respectively the OH minus and the amount of H2O plus that is going to react. So we can go directly to our equation for the reaction of the acid and the base in order to generate water. So the initial amount that we're going to have of H3O plus, it is going to be 0.025 mole, and in this case all of the ice table is going to be in terms of mole, and the amount of OH minus it's going to be 0.006 mole. The amount of water doesn't matter because this is a pure substance, right? So from the one-to-one relationship that we have, we can notice that the limiting reagent is going to be the OH minus. So the amount of change is going to be equal to the amount of OH minus that we have. Thus, at equilibrium, we're going to have 0.025 minus 0.006 of H3O plus minus, which gives us a value of 0.019 mole. And of OH minus, we get something close to zero. So now, in order to know the pH, remember that pH is equal to minus the logarithm of the concentration of hydronium ion. In order to know this, we need the concentration of H2O plus, which is simply the amount of mole divided by the final volume. So we started with a 50 milliliter sample and we added 15 milliliters. So we are going to have 65 milliliters. But molarity is moles per liter, not moles per milliliter. So we need to transform this using a conversion factor. Milliliter and milliliter are going to cancel out. Okay? So the result, it is going to be a concentration of H3O plus of 0.2923 molar, which in turn, after taking the logarithm and taking the negative value, it's going to give us a pH of 0.53. And that would be our final pH for this solution.